Okay, so continuing our DSS series, yeah, we are on trees question. So, given a binary tree, as you can see, and another thing is a vector. Yeah, you have to make sure that this vector represents the pre-order traversal of this tree. If it does not, then you have to return -1. No, you can do some modifications to make it match this vector. If there is no way to match the vector by your pre-order traversal, you return then -1. Okay, it's not exactly equal to your pre-order traversal if you see, but you can swap 3 and 2 to make it equal. So that's what we are doing. Allowed is the operation to flip a binary tree. What it means to flip is when you say that I'm flipping around the node, let's say 1 remains intact, but everything else change down from 1. Okay, only the only the subtree, only the down part of 1. So 3 becomes like everything which is coming on the left hand side will come on right hand side and vice versa. So checking would be simple. Go do a pre-order traversal on a tree. This is how it will look like a bee. I'm just completing it. So if you found the value not equal, not continue, then return 0. If you found value equal, but your left value is not equal to the next value, which means this not, let's say 2 is not equal to 3, what we do? We flip, and we flip in a way that we just swap root left, root right, and we call on left, right, should be fine. Yeah, because that's the whole way. So let's say you flipped. 2 is not equal to 3, you don't see anything, you just flip. Whatever it is, let it be 4 or 8, that comes over here, you flip. That's what the only operation what you can do. Now you are on left part. Your mm, yeah id, mhm. How will you shift your id then? Because let's say your id, yeah, your id was, let's say it was not matching with 2, it means it was something like 3. Or if it was not something like 3, let's say it was 8. So then you flipped, then you have, let's say, 3 over here. 3 is not equal to 8, so you return 0 straight away. But if it was matching with 3, so it should match with 3, and then it should match with 4 and 5 also. This is the condition. If it's not, it's only matching with 3 and have no children. Like 3, my case, 3 has 2 children. So in your case also, 3 has to have 2 children if you want to match the both the things. Yeah, that's how you do it, like, and solve. Hmm, hmm, uh, can we say RQ equal to yeah, v root is fine, pass the root, id 0, id is fine, and yeah, should be fine. Now the thing is, we are not even checking whether the size of voyage is equal or not. Hope so they are making it equal. Yes, like keeping it equal. Let's okay, return 1, man. If that's fine, return 1. Ah, man, so you don't only this yeah, basically if that is 0, then you return something like -1. Else you return something like let's say r. R is rs. Rs is result. Rs, and whenever you do swap, you say rs dot push back root val. Should be fine. What about the case when you actually do a swap and it adjusts to make a match? Because in this way it was not possible. This way it's possible. This way it's completely equal, so you'll not do anything. It would be empty vector. Yeah, it's returning empty. Issue. What's an issue? Ah, issue is basic issue. And if root becomes equal to null, return one man or what? Don't know really. Yeah, and like your null matches with. You don't need to do id plus plus for that. What's the issue? It's just directly calling on left val. What if left val is yeah only if left exists, then it has to be equal with this. Mm, uh, it's an issue, man. So you are on one and id is zero. Root val matches. Column left id plus plus matches. No, don't match. Which back root val? Swap root left, root right. Column root left matches. So this guy got a match. He's called on root left. 1, 2, 3 minus 1. Let's see what's issue. So why do you return minus 1, man? Right. Hmm. Particular stay. Stop. Hmm. Okay. Let's just do a quick checking. Uh, possible. Say what we do. 3 के नीचे 5 और दे देते हैं लाइक ये टेस्ट केस चला रहे हैं 3 के नीचे मैंने दे रखा है क्या 4 5 एंड मैच कराना है आपको 1 3 2 4 5 नल नल से आपको मैच कराना है रियली मैन श्योर मैं इसको विजुलाइज कराता हूँ ठीक है 4 5 सही जगह आ रहा है इसको विजुलाइज कराता हूँ ठीक है 4 5 सही जगह आ रहा है. So answer is yes in this case. But what happens when we do something like two remains with two? Like yeah, like if I do something like what say man, what say? Let's add 4 over here and remove 5 from here and yeah, none, just one none. So now the scenario is like two has something four and the reversal of it would be three has five. Three should have five and it should have like four. Three has five, two has four. 3 has 5, 2 has 4. Yeah, actually, like voyage may it will come like that, right? Stuff. Let's submit, man. Like I think it should be fine. Yeah, let's submit. -1 वाले केस चल रहे हैं bro. Whew, fine man. Like really, these can like again. I would not say this as a complete implementation question, but like looking, it looks like it's an implementation. Just you just need to see or yeah, that's come with a kind of maturity of problem solving. I call it that. Yeah, till the point you do it, you are quite unsure about it. Is it really like just only checking the numbers, like whether it is equal or not? If it is not equal, then I am only left with one option to swap and I cannot backtrack a swap or backtrack also doesn't make sense because previous configuration was not good. If this configuration is still not good, you return 0 straight away. If this becomes good, then you proceed to downwards, like to see whether just by making this configuration good for the level equal to X, whether all the levels beyond X are good or not. Like if, yeah, like in this case, 3 4 5 becomes like this 3 4 5, it's fine for us. But what if the required thing was 3 5 4? In that case, we will not be able to like do it. Yeah, even if the first configuration is like yeah first level would be good the next level you will have some problems. Or what if like instead of like this 4 5 came on the left hand side and it's a part of 3. What if the 4 5 was part of a 2, like 4 5? So when you swap it, you take 3 over this side, but you forgot that okay, 4 5 has to be on the left. Now 4 5 uh yeah like yeah are you getting like so basically this is the whole thing that you have to check for a node. uh, Pre-order, the only thing about this is pre-order is like pre-order, like you go from index id 0 to n. You don't have to be more tricky with it, as in order, right? Somehow in order becomes trickier because the first node is essentially not the first node, it's the leftmost node, something like that. So that's why the yesterday which we did the question of serializing, deserializing in order was not making a lot of sense there. But pre-order somehow yeah like was better and easier as compared to in order in that aspect. Sometimes you can make a choice. Yeah. Okay, that's about it. Bye. Bye.